At the plane y is equal to -2, it cut the y-axis at y is equal to -2. Then that line okay, imagine there's a plane that cut, and I don't draw it because it may mess up the things here. But imagine that plane will be like this, right? It cut at y is equal to -2. So the line, the blue-green line here, will cut the plane OXY here at this green lines. And this point, right? This point, let us call it the point M. What is the coordinate point of the point M here? The coordinate of this? X is equal to 3, Y is equal to, oh, this is -2. Sorry, that's what I meant. -2. Then these two, yeah, very good. Thank you. These two lines, the Y, the green and the blue lines here belong to the OXZ coordinate. So OXY, I'm sorry. Then at that point, OZ will be 0. So this belongs to that plane. So Z should be 0 here. Okay. You all see it? Okay. Then the point, the line that goes through this point M, parallel to OZ coordinate. How does it look like? It will parallel to OZ, right? It will be straight up, go through this point. Okay. Do you all see it? Okay. And if we are looking for the point A here, 3, -2, Z is equal to 3. This point A should belong to the purple line. You see? Okay. And the point M here, the distance from the point M to the point A will be the same as the distance from here is 0, right, to 3 here. Okay. So you see? And this is the point A, satisfying the condition here. This is A, 3, -2, and 3. You see the line, suppose, let us call it, this point is 0, it is at the origin. This is M, this is A, and let us call it B here. Then the plane containing the OZ axis and the purple axis, right? That plane. So the AM will be parallel to BO, right? Go straight up. And the AB, the vector or the line AB will be parallel to OM. It should remain these properties. Okay? That is how you can find a coordinate and construct it properly. And we did it yesterday. Yes. Yeah, and the test, we can take the point in the test, but I don't remember. Just pick a random things here. A here. Yeah, I think. I'll consider that depending on how the whole class do, okay? But we should do it this way, should be precisely here. And the point here, the projection should be indicated clearly. Otherwise, you cannot claim that A will be this coordinate because I cannot see if you don't draw this line, right? You cannot tell. Or some people may draw it without the coordinate, they just draw it imaginally, then this line, it doesn't make sense, for example, okay? So that is just some review. And now, in the 3D dimension, there's something called dot product. The definition of this is that, okay, a dot product of the two vectors, A and B, will be the summation of the product of each coordinates here. A1B1 plus A2B2, A3B3. It's quite easy, right? Just first guy multiply with the first guy here. The second guy multiply with the second guy here. And the third guy multiply with the third guy here. Okay, and this sum is a number, or we call it a scalar, right? So that is why it has a name, scalar product. In vector forms, in 2D, it is written like this. So remember, we build up on top of what we have studied before. So whatever true in 2D should also be true in 3D. Okay. And here are some properties of the dot product. A times A dot A will be the magnitude of that square. Second one, A times A dot B will be B dot A, it's the same. A times B plus C is equal to A, the distribution rule, right? A dot B and A dot C. And 0 is a 0 vector, and dot product of 0 with any vector will give us 0. And suppose here C is a scalar. So you see that C is not both, right? A and B are both in this case. So it indicates that C is a scalar, A, B here are vectors. Okay? Then we can do that C time multiply with A dot B. Yeah. And here is the geometric interpretation of this dot product. So the angle between vector A and vector B, we call it angle theta. So it is defined to be the angle between the representation of vector A and vector B here. Okay, if A and B are parallel, then the angle theta will be 0 or pi, this definition. Okay, if they're parallel, then angle theta between A and B, the angle will be 0 or pi here. Okay. Here, from that properties, from definition, A dot B will be the magnitude of A times magnitude of B and the cosine of the angle between them. Okay. Or corollary, we have that in order to find the cosine angle here between two vectors A and B, we divide both sides by the magnitude of these two, providing that A and B are not zeros vectors, okay? Because if it is 0 vector, the magnitude of that will be 0, and something divided by 0 doesn't make sense. So that is why we have this here, okay? So before doing that, let us play with some example. There's a yeah, just from definition here, Tobias. Let us, yeah. from definition here, some properties, cosine angle will be like this. Okay. You see it here. That's just a few example. Now let us play with something example here, and you see it better. Suppose we are given the vector A let us write it this way. Okay, it will be -1, 7, and 4. Vector B is 6, 2, -1/2, right? Then what is the dot product of A and B? Very good. Okay, then what is A1 in this case? Thank you. And thank you, Walid. And yes, be careful with the negative signs, it's very dangerous. It will be -6, right? 14 and -2, very good. So it will be 14 minus 8 will be 7. Very good. Sorry. Yeah, thank you. Too bad. 6. What is it? 6, right? Yeah. Simple things. Okay. Then we can write it differently, right? If remember, I, j, and k are unit vector. What is I? The vector I is the unit vector in the OX axis, right? It means that the length in the X direction will be 1, and in Z and Y and Z will be 0. What is J? What is it? 1. And K? 0, 0, 1, right? These are unit vectors in 3D. So it means that for any vector A here, we can write it as a sum of 3, the basic vector or the unit vectors here, which is -1 times, very good, thank you, Aluk, plus, good job, 7j and 4k, right? Okay, very good. This is the vector I. We can do the similar things with vector B. Vector B here will be 6, 2, -1/2, right? It will be 6, 2, -1/2. Let me write the unit vector in red here. Okay. The properties of these will be that when I dot product with J, what is it? Yeah, it will be 1 times 0 plus 0 times 1 plus 0 times 0, right? And finally, it will be 0. Makes sense. So at the coordinate, the 3 unit vector will cancel each other, or they are perpendicular. Very good. They're orthogonal. The same story. We see that A times K, I times K will be 0. Yes. And J times K will be 0, right? Very good. So now you can think about the dot product this way. If we write A dot B here, we can imagine that it will be the product of these guys. Let me write it, yeah, smaller. Sorry. Okay, negative 1i plus 7j plus 4k, right? Times the vector b would be 6i plus 2j minus 1/2 k. Do you agree? If we write this way, we can use distribution rule. The same things with numbers, right? Then if we distribute this guy to this, this, and this, right? What do we have? First, this guy will multiply with 6i here, right? Very good. And the second terms will be negative 1i times, yep, times 2j and yes. Luckily, look at this. I times I, what do we have here? 1, right? And I times j, 0. And I times k, 0, right? So the same properties, it will be applied to the second terms. 7j and j multiplied with I will be 0, so we don't have to write it. Let us just count for the product, where 7j times 2j here, right? And the last one, the k component, it will be and what? Negative 1/2 k, right? So in the future, if you write this way, what you care is the non-zero terms, right? Or in other words, we can write it as here, negative 1 times 6, the number we just factored. It would be negative 6, right? I times I will be 1. Yeah, I dot I here. Plus 7 times 2, j dot j plus 4 times negative 1/2 k dot k. Okay, it will be negative 6 plus 7 times 2 plus 4 times 1, negative 1/2, and finally it will be 6, like normal. Okay, this is a different way to write it in details and understand it a little more. So, is that okay up to this point? Yes. Then let us do some more example here. Example, if A and B have the length 4 and 6, the angle between them is pi over 3. Find the dot product of A times B. So look at the formula for this. A, pick whatever way you want. And this is just an explanation and make it clear, okay? So you can memorize the fast way that you're comfortable with. A times B here, A dot B will be from this formula, absolute value. Yes, thank you. Which will be cosine of pi over 3. Very good. And cosine of pi over 3 will be, yes, 1/2. It would be 12, right? Very good. And now find the angle between the vector A and B here. So if A and B here, they are non-zero, right? So we can find the vector between them very well. Then we can apply this formula, right? You see it? So this formula is from the above formula. We divide both sides by absolute value of A and B here. So what is the magnitude of A in this case? Let us do it slowly. Very good. 2 squared plus 2 squared plus -1 squared, right? Which is 9, square root of 9, or it is 3. What is the magnitude of vector B here? Right, and in the end, it will be 25 plus 9 will be 34, 38, right? Okay, 38. Then we cannot, simplify it further. Okay, therefore, cosine theta will be A times B, right? Divided by magnitude of A times magnitude of B. And A times B will be like this, right? Very good. And the denominator, we found it already, which is 3 and square root of 38. Okay? From this will be 10, minus 6 will be 4, 4 minus 2 will be 2, right? Okay? Then, therefore, we take the inverse function, right? The inverse of cosine, inverse the left-hand side will be cosine inverse of 2 over 3 square root of 38. Remember, when you use your calculator, it is computed in radians. Okay? Remember to double check it. Then the angle theta will be, try it yourself and double check. Or in degree, it will be 84 degree, okay, approximately. Yes, very good. Thank you, Alok and everyone. Do you all see it? Do you all get the same result? So now we can move on to a new thing. Okay, very good. So there are some special case when it is perpendicular, then the angle between vector A and vector B will be pi over 2, right? Pi cosine of pi over 2 will be 0. Therefore, if it is orthogonal, we call it perpendicular or orthogonal when the dot product between them will be 0. Okay? Yes, this is a very important properties. And here show that this vector is perpendicular to this vector. In order to show that, we need to find the dot product between these two, right? We need to find the dot product of 2i plus 2j minus k dot 5i minus 4j plus 2k, right? As we have done a few minutes ago, this dot product will be, what is it? Plus 2 times negative 4. Let us write this way, okay? Yeah, or minus 4 times 2 is the same thing. Right? We just pick the parameter coefficient of these guys, multiply to each other, sum them up. That's it. And we see that this is 10 minus 8 minus 2, and it would be 0. Because the dot product is 0, then we conclude that it is perpendicular or orthogonal. Okay? Are we good? Good job. These are not very difficult, but yeah, let's go quickly. Here, because of the nature of the angle, if the angle is between 0 and pi over 2, then A and B will be pointing at a similar direction, right? The general direction. If they're perpendicular, then dot product will be 0. If this angle between A and B are acute, it means that these two vectors are pointing in the opposite direction in general. Okay? Very good. And there are some special situations when theta is equal to 0, right? When theta is equal to 0, then these two lines are pointing at the same direction, right? They're parallel, but at the same direction. If theta is equal to pi, what does it mean? Yeah, they're parallel but pointing into different direction. Very good. So, good job. And here we will study some new concepts. This is, we call it direction angles and direction cosines, please. Okay? Look at this box here. The OX, OY, and OZ here. For any given vector A in purple, the angle between this vector and the OX axis, we call it alpha. The angle between A and OZ, we call it gamma. And the angle between vector A and OY axis, we call it the angle beta. So these angles, suppose they are between 0 and pi over 2. Then, so remember that direction cosines can be computed using the dot product between the vector I and the unit vector in the x direction here, right? Let me use a different color. The vector I is this guy. Then the dot product of A times I divided by the magnitude of these two give us the cosine of the angle between them, right? Therefore, it is like this. Or it will be the coordinate in the x direction of vector I divided by the magnitude of this. Okay? Vector A times I will be A1. Similar story. The angle between vector A and OY axis, it will be A2 divided by the magnitude of A. And similarly, the angle gamma here will be A3 divided by the magnitude. Okay? Look at this. It's very special that if we square these equations, 8, 9, and this one, we see that cosine of square of alpha, cosine square of beta, and cosine square of gamma will be 1. Why? Because cosine square of alpha will be A1 square divided by magnitude of A, right? Cosine of beta square here will be A2 square divided by the magnitude of A. And cosine square of gamma will be A3 square divided by the magnitude of vector A here. We sum them up and you see that it is equal to 1. Or in the future, I think this is the best way to memorize and how to compute the angle between the coordinate, the angle direction. So A here, we see that A1, right? A1 will be from this relation. The relation 8, 9 here, we see that A1, we can write it as the magnitude of A times cosine alpha. Similarly, A2 will be magnitude of A times cosine beta and magnitude of A times cosine of gamma. From the properties of vector, we can, each of them has a term of magnitude of A, so we can factor it out, right? Then we decide both side, left and right hand side, by the magnitude of A. The left hand side here, what is it? This vector, right, will have the same direction as vector A. Do you agree? Yes, very good, Alok. So it points the same direction, but the magnitude of that will be 1, right? So we call it the unit vector of vector A. So let us call it EA. It's very interesting that EA will be having the X, Y, and Z components are exactly the same as the angles between the line, axis, right? So now I believe that the equation 11 is the best way to memorize these lessons. So I normally memorize it this way. So now let us find the direction angle of the vector A here. So we want to find the direction angle of vector A. So let us find the unit vector in the same direction, right? In order to find the unit vector here, right, we need to find the magnitude of A. Now let us just call it. And what is it? Yes, thank you. Look, we 1 plus 4 and plus 9, 14. Very good. Therefore, the unit vector in the direction of A, let us call it EA here, right? It will be 1 over magnitude of A times the vector A here, right? It will be 1 over square root of 14, 1, 2, and 3. 3. Or we can write it as 1 over square root of 14. What is the y coordinate? Yes, and very good. Therefore, the angle, the direction angles will be cosine alpha will be 1 over square root of 14. Very good. It means alpha will be okay. Very good. And cosine of beta will be yes. Therefore, beta will be very good. Use your calculator to double check it at home. And what are they? Cosine gamma will be very good. Okay? Does it? It's not very difficult. So are we good? Yes. And here is the projection. So if the vector PR, we call it vector B here, and PQ is the vector A, then the projection of vector B, which is PR, onto the vector A will be the red line here. Okay? The angle between them, let us call it theta. If it is from pi 0 to pi over 2, and we see that this vector, the projection vector, we call it this, we point this in the same direction as the vector B, right? Or if vector A and vector B are pointing in the opposite direction, or the angle between them are larger than pi over 2, smaller than pi, then we know that the projection vector S, the red line vector here, will be pointing opposite direction of A. Okay? And yeah, by doing some computation, yeah. Let us go home and read it yourself. And next time we'll try to do some more example here. Or I will upload some explanation about this. So, class dismissed here, and I'll see you next week.